Oh, I got bright all of a sudden. All right, so the title of the notes is Solving Absolute Value Equations. Solving absolute value equations. All right, so I don't have a lot to talk about with this. I'm just going to go straight into examples. So the first example is 6 plus 3 times the absolute value of 9k plus 4 equals 99. And typically when I write the absolute values, I make them a little bit longer in an equation so you can tell it's not a 1, because that can get confusing sometimes. So when we're solving equations, we do PEMDAS backwards. Do you know what I mean when I say PEMDAS? Please excuse my dear Aunt Sally. So PEMDAS is what you do if you're just plugging numbers in and you're figuring out what something equals. If you are trying to solve for a variable, you do that backwards. So off to the side of your paper, go ahead and write that our first step is going to be to add or subtract something to get it away from the variable. Our second step is going to be to multiply or divide stuff to get it away from the variable. Our third step would be to deal with exponents, which we're not going to deal with today. And then our last step would be to get inside the parentheses, or they could be other grouping symbols. And today, our grouping symbols are absolute value. So we're not going to do P, we're going to do like absolute value as our last step, okay? And then once you get inside the absolute value sign, then you go through the list again. So first step, is there anything we could add or subtract to the other side to get it away from the K? The 6. The 6 is like we're going to work our way from the outside to the inside. So the 6 is the furthest thing away. So we can minus the 6. Perfect, yeah. And then the next step is to multiply or divide something over, and I already heard it, but does somebody else know what we do next? Divide by 3. Anyone know what 93 divided by 3 is? 31. Okay. And then there are no exponents to get rid of. So our last step is to get inside of the grouping symbols, which in this case isn't parentheses, it's an absolute value sign. Now we have two options. We have that the stuff inside of here could have equaled positive 31, and so it was positive 31. Or the stuff inside of here could have equaled negative 31, and then the absolute value signs forced it to become positive. Does that make sense? Two options. So when we continue, we have to do this two ways. We say 9k plus 4 could have equaled the negative version, or 9k plus 4 could have equaled the positive version, and we solve for both. So we should get two answers when we do these problems. So that's the special trick. That's it. That's like the whole special trick for today, is just to do two of them. All right, so now what am I going to do? Minus 4. So minus 4, minus 4. Yeah.
Can you explain how you got to the 9k plus 4 equals 31?
It's just whatever's inside the absolute value sign. It could have equaled positive 31, and then when you took the absolute value of it, you got positive 31. Or this stuff all could have equaled negative 31, and then when you took the absolute value sign of it, it made it positive. And so that's why we do two options, the positive and the negative version. Yeah. So we have 9k equals negative 35, okay? And we do the same thing over here. And we have 9k equals 27, okay? And then what do we do? Divide by 9. Does this one divide evenly? Yeah, 35 doesn't divide by 9. Is there a number we could divide out of the top and the bottom? Did you just spit your gum in the recycling?
Just further spit it closer.
It's fair. It's fair. It's questioning. It'll dry up before, you know. That's good. Huh? Yeah. There you go.
I mean, they go to both of the same thing, so I mean, it's not really cool.
They do not. Do they really?
If the janitor comes around and just picks them up and throws it in there, I've never seen anybody have like two.
That's devastating. I'm devastated. All right, 35 over 9. Is there a number we can divide out of the top and the bottom to simplify it? No. So negative 35 over 9 is totally fine. Students often ask me, Miss Rice, can I write that as a decimal? And the answer is yes, but I'd rather not get out my calculator, so I'm just not going to. And then also, I prefer, if this is going to be a decimal where you'd have to round it to write it down, I don't want you to write it. I want you to just write the fraction. Yes? No, we already tried. All right, and then 27 divided by 9 is 3. All right, example 2. Four minus 8 times the absolute value of 7n minus 8 equals negative 12. So now what do we do? Minus 4. Okay, so I'm going to go ahead and write out the steps. We always start by adding and subtracting something to the other side. Then we multiply or divide to the other side. Then we deal with our exponents. And last we do our grouping symbols, which happens to be an absolute value sign this time. So first we said we're going to subtract 4 from each side. So we have negative 8 times the absolute value of 7n minus 8 equals negative 16. Okay, and then we're going to multiply or divide something to the other side, and so that means we're going to divide by the negative 8 that's in the front. Before we do that, I'm just going to cover this up. Could we ever say the absolute value of something equals a negative number? No, why not? Yeah, because that's how absolute values work. They should turn something into a positive. So if you're doing a problem like this and you get to this point, that means there's no solution to the problem. Does that make sense? You can't possibly say the absolute value of something equals a negative. That's not possible. Yeah. Yeah, so we were saying if you're working on a problem and you get to this point, you say, oh, my absolute value equals a negative. Then you say no solution, because an absolute value cannot spit out a negative number. That's not how they work. Okay, now for this problem, we did have a negative 8 in front, and that's going to save the problem. But when you guys are working on the worksheet for today, there is one problem where the answer is no solution, and that's because you have an absolute value that equals a negative, and those are very easy to skip over and miss and accidentally solve. Okay? All right, so now we said we need to divide as our next step, so we're going to go ahead and divide by negative 8. So we have the absolute value of 7n minus 8 equals 2. So at this point, we say the stuff inside could have equaled positive 2, and so it spit out positive 2. Or the stuff inside could have equaled negative 2, and then the absolute value made it spit out a positive 2 again. So this is where we say, let's do two different equations. We're going to do 7n minus 8 equals negative 2, and 7n minus 8 equals positive 2. So what do we do next? Add the 8. So plus 8 plus 8. So we get 7n equals 6. Okay. And then over here we're going to add 8 and add 8. So 7n equals 10. Okay. And then what do we do? Divide by 7, divide by 7, divide by 7, divide by 7. So we get two fraction answers. What are the two fraction answers? 6/7 and 10/7. I would say that by the time you get to upper level math, we prefer improper fractions instead of mixed fractions. We do not often, it's a good skill to have, but it's in high school, we always go with improper. Yeah, good question. Okay, how are you guys feeling about those? Good? Okay, so now we're going to practice those. Have fun. Woohoo! I'm excited for more math.